Hi everyone. Welcome to the next session here in the afternoon. We will now have a guest lecture from Katja. She actually attended this course last year as an exchange student who was here for one semester or so, and is now a PhD student with our university. And she will talk about life cycle and project management. And thank you very much, Katja. We look forward to your guest lecture. Please go ahead.
Okay. Hello, everyone. My name is Ekaterina, or you can call me Kate, Katya, as you prefer. And today we're going to talk about software engineering, life cycle, and project management, some frameworks, and best practices to conduct your work. Couple words about me. Currently, I'm employed at university as a researcher and at Technology Campus Graphinou. I'm doing mostly research about AI for context recognition. Also, I'm a software engineer and computer science lecturer at opposite university. I have 5 years of industry experience in software engineering and a couple years in teaching. And also, if you want to connect or ask some questions afterwards the lecture, you feel free to contact me on LinkedIn or by email. Our plan for today, firstly, we would talk about what is software development life cycle is like, which stages should we go through to implement any project, which approaches currently exist in profession field. We would talk about we would go through some special techniques for project management related only to data science. And also we would take a look at some extreme programming tactics. They are now implemented in our industry, but they were good for your small pet project or educational projects or small startups. So first of all, what is life cycle of any software? As we call it, we can call it SDLC. Firstly, it's a model which takes into consideration all stages of creating any software. And this cycle is a structure of some steps which should be taken to achieve our project from the idea to the final support after release. And the main tasks of this approach is to provide our product with sustainability, with trustability, and also to support our clients. So we're doing exactly the same thing as we expected to do. So which stages our life cycle is made from? Can somebody tell me, as DLC is a cycle, where the start of this cycle? On which stage? Can you talk a little bit louder? Planning. Okay. Why not analysis? No. Not that? Okay. So you're right. The first stage is actually planning. On this stage, we need to think what we are doing. And before planning, we're taking so-called initial step. On this step, we can actually think about three main things: is why we are doing our project, for whom we are doing this project, and how we want to manage it. Do we want to just go with the flow or constantly talk with our stakeholders? So key stakeholders is somebody who is actually having the money to pay us to do something. So they having this meat, this stake, and we need to somehow coordinate with them so we don't have to redo everything on the last stages of the project. And also on this stage, we should select our management tools. what do you think, which management tools can be implemented here or should be taken in consideration? What is management tool in general?
Jira, like project management tool like Jira, you can use.
Okay, Jira is a framework, is a software for managing the tasks for flexible project management frameworks. We would talk about it later, but here, by management tools, we think about the approach. So are we going with a constant checking with our stakeholders about things what we are doing, or we would write down all the software requirements in the initial stage and then just implement them and involve our customer only in the very, very end. So we can just sign the papers about we are done, you're paying us money, we're delivering your software. After the initial stage, where we document everything that we need to do, we go into the actual planning stage. It's the first stage of the product, when we should definition of done. So when the project is over, because no project should be without end date. If you sometime will hear like our project would last lifelong, it won't happen. It's not a project. Every project should have an exact date. By that, it should be done and only supported afterwards. The second thing we need to do on a planning stage is who actually would work for us. So before we had like 3 people with a good idea of changing the world, and now we need actual developers to do that. So this stage, we trying to build our team. And also calculate how much money we need to pay to that guys, which infrastructure we need, and by which time we need. For example, maybe in the beginning, we don't need a big server. We need just personal laptops for a development team, and we can deal with the expensive hardware afterwards. And after the planning stage, we are going to the main stage as a development stage. As an intern software engineers or as a junior software engineers in company, you will see only this stage. Here, no project management, only tasks, testing. So a lot of developers work only here, but all the infrastructure, all management doesn't bother our developers on the development stage. And after development stage of the project, we would get to the control stage. Here we need to assess all the risks. So the management will see, okay, we done something, it's working quite good, but what would be if we, for example, initially we thought that our system would have only 100 users, and now it's going better and better, and we have 1,000 users per day, per hour. Would our server crash or not? We need to assess this risk because buying a new software sometimes is much more expensive than it's supposed to be. And if our risks to overloading the system with users are very small, we basically don't have to purchase much more expensive stuff. Then it's can be done with the cheaper stuff, but slightly risk of server failure. Also here we are tracking performance of our team, doing huge reviews of code and thinking maybe we need to motivate them better. Maybe we can say goodbye for some part of our team because we don't need them anymore and developers are expensive for the company. And also here we can talk to our customer about his level of satisfaction with our results and how our software can be better. So, which approaches to the project management currently exist? There's 4 huge groups. We would talk about all of them. First group is a predictive form of management, is good for this situation when all the risks and all the possible scenarios are pre-known. So it's fully developed area, for example, creating websites for online stores and so on. It's a pretty known field. We don't have a lot of risks here, so we can theoretically write down all the requirements for our software in the beginning, and then just go with our development process, and in the end, show it to the customer. Here we have, as we can see on the graphic scale, predictive approach. We not making huge changes on every single step of our project, and we deliver really low frequency. So we deliver at the perfect scenario only one time in the end of the project. In real life, predictive approach doesn't work that well because we've done something, we delivered to the customer, and customer told like, no, it's not what I wanted. You need to do something about that. We can show the customer at that scenario all the requirements for the software that he told us in the beginning, but in real world, customer don't know what he wants. So it's really hard to get fully specified set of requirements for our software. So predictive approach was quickly substituted by iterative approach. On iterative approach, we have some small loops where we can show our product to customer, and then have some feedback, implement it, and go on with it. So here we have also small degree of change, but we deliver really frequently. So for example, every single month we show our product to the customer, and going to the end of the project. Third approach is incremental approach. Here we have a huge change of our code base of our project, but deliver really on low frequency. That means we are trying to do some part of the final project till it's fully done, and then deliver it to the customer. For example, we're trying to create the car, and in incremental approach, we would on the first stage, we would invent a wheel, then we would sell it to the customer. Second step, we would create a small scooter with 2 wheels and deliver it to the customer. After that, we would modify our scooter to 4-wheel scooter as a quadricycle and deliver it to the customer. And on the final stage, we creating some kind of roof on this 4-wheel scooter, and it's a car, and it's our final project. And the most useful flexible approaches is the combination of, for example, when you are trying to pass your Algo and DS class, you can try to write your code and pass the test, and you can create a lot of attempts. And every single attempt, you can pass 1 test, for example. So when you're modifying your code step by step with small packages and delivering to the testing system or in the real world to the customer, this is the flexible approach to project management. Let's take a look one more time in the predictive approach. Here we have our variation of life cycle, but it looks like a straight line. So as you can see, there is no turning back on any stage. We should perfectly analyze and finalize our analysis into some documentation, sign it with our customer, and only then we can move to the actual design and planning of our system. And after design is over, we should finalize it and never change it, because on the building stage, we are building our software. Here also we can write some unit testing, not with the actual environment of our customer, but make only tests which are our software engineers write. And after the build stage, we go into the production testing. That means we are delivering our system to customer, and customer can just try it out say, okay, I like it, or I don't like it. And in that scenario, we need to start from the very, very beginning. Or if the customer actually like our system, we can say, okay, it delivered. Now we can think about supporting this system, or we can just say, okay, we are done. Here's your all full code base, your licenses. Now it's your own responsibility to run the system on your machines. This approach was adopted by waterfall model, which we would talk about later. Now we're talking about approaches, and the waterfall, maybe some of you already heard about that. It's a framework, not an approach. What about iterative approach? As I already told, here we have our some kind of predictive approach, but cycled in an iteration. So initially we're planning our project. When we're starting on every single iteration, planning, doing something, delivering, and only when all the iterations are done, our customer is satisfied with the result, we can say, okay, now we deploy, and now we will think about support or not supporting. Incremental model. Incremental model is a lot of pre-planned models, just going with the flow. With on the end of every single iteration, we have working product, working prototype, and we are moving to the end of our project. To be more clear, what's the difference between incremental and iterative approach? For example, we are trying to create the photo of this nice gentleman. And in iterative approach, firstly, we are sketching some contours with the black and white paper. And after that, we are adding colors, shades. And on the last iteration, we have our final result. For the incremental approach, we are working on finalizing every single piece of the image. For example, we're starting with a white board. Then we are working on this small section of the picture, and every single increment, and in the end, we are getting away with the full picture. Now, what's the agile? Does somebody already heard the term agile? Okay, what is that?
For example, and they have sprints, phases of working, but they have a specific goal that deliver like this feature, and in itself it's a fully stable product, and they want to deliver that to the customer, so the customer can give feedback on the product and features, and then it's easier to figure out if the customer actually wants that or needs it, or if not, and then in maybe 2 weeks or 3 weeks or 4, then when the team knows what they built is actually not good or not working, then they can have the next sprint to find another better feature, then give it back to the customer.
So as you mentioned, the flexible approach is basically the first approach, which are actually taken in consideration when that we need to redo something. So as you mentioned, that we deliver it to the customer like or not like it. And if the customer doesn't like our product, we actually need to do some changes. So we are circling back, and our agile looks like this. We have sprints. Sprints can be, as the team would decide, from 1 work week, so it's 5 working days till a month. And every single sprint works as we are, first of all, have a meeting as an assessment of the tasks. So we think, okay, we have capacity of 3 people. Every single person work this same amount of hours, and we can take only a limited amount of tasks. We estimate these tasks. We mentioning, okay, they are going to this sprint. Then the work starts. Every single programmer, software engineer, designer, analytics work on his tasks. And in the end of the sprint, we have some sprint retrospective when we are just sitting in the meeting and telling each other what we have done in this period of time and what can be done better, which were struggles, and so on. Then our next sprint is starting. How does team of this flexible approaches should look like? First of all, if we have a lot of interpersonal communication, so everybody should know everybody on a team. So team shouldn't be that big. It's usually 5 to 12 people, but as practice shows, more than 7 to 10 people is hard to manage. Also, our team should be cross-functional. We should avoid the situation when for example, only one software engineer know how this thing work, and so he not allowed to take any vacation. He not allowed to be sick or travel somewhere because nobody else know how does his stuff work. So our team should be cross-functional. Everybody should be aware of what other person is doing. Also, our team should be minimal dependence on the department. That means that only our team should be autonomous. Team should be able to decide what they are doing, and not somebody else, not from the team, should manage their work. For example, telling like, okay, today you're working on Scrum methodologies, on your tasks, and tomorrow every one of you go and fix that server in the opposite building. No, our team should be self-organizing and independent. Which instruments are actually used for flexible methodologies? Does anybody had an experience of work with Jira, Redmine, or Trello? Okay, can you describe your experience and with which system you worked? And
Well, like in Mexico, I studied software engineer. So basically, we made a mobile application following the Scrum methodologies. In that case, we use Jira with sprints every week for like 6 sprints. We were a small team of 4 people, 4 to 5 people, I don't remember exactly. And we were delivering continuously value to our Scrum master.
Yes. Does anybody had an experience working with a Redmine or Trello? Not really? Yeah. It's foreseeable because the Jira have some form of not monopoly, but it's basically in every single company, and it provides free licenses for students, and it's really not really user-friendly to use, but if all companies are using that, so we need to learn that, how to deal with it. Also, there is a Redmine and Trello frameworks. As an advantage, I only can say that Redmine supports Git and help desk integrated in it, so we don't have to dance around like with Jira situation. If we want to connect to the our system version network, SVN. And the hugest advantage of Trello, it's free. It's would be free. Doesn't matter, are you a student or are you a company? So basically it's the same thing as Jira, but with much less functions, but it's free. So let's sum up all our methodologies. Do you think which methodology is better, or which is more appropriate to use in some specific situations? Yeah.
It depends on the software you or the value you want to deploy. It depends on the area or the client.
And maybe can somebody tell me when the predictive methodology would work better than, for example, flexible methodology?
Government projects.
Can you repeat this?
Maybe government projects.
Yes, mostly. And maybe for projects or tasks where we cannot increment. For example, you cannot perform testing of the system somehow. Oh, we need to evacuate? No? Okay. Okay, so the predictive system works good with the governmental projects and with the, for example, if you need to test one exact module, you cannot do it iteratively. For example, you are setting satellite to space and you cannot set it to space, then okay, something doesn't work, we return it back and we set it again. Here we have only one way, so we need to think before doing something. And now let's take a look to the exact frameworks and practices with each of approaches we talked about. First of all, water flow or cascade model. It's appropriate model for implementing predictive approach. Can somebody look at the scheme and say where only one arrow can go back upwards our water flow?
From testing to coding?
And why?
Because if something fails, you can re-code or rewrite the code.
But is this testing some testing which our customer do, or is it testing which done by developers? Okay. Okay, so as we talked about, as advantages is fixed amount of stages, so we would definitely deliver on pre-planned time. We have 100% definition of done. So if everything is done by we can tick our requirements in some form of document, means we're done, we have clear structure. It's very easy to adapt for a small, for example, startup, or if you're starting your company and it's your first order, it's the easiest model to go, and you basically can start with it. Yes, it's not perfect, but it's easy to manage. And if you are not having some degree in management, even the software engineer would be okay with that. And I know that a lot of software engineers hate management with their endless meetings, but here it's very easy to adopt, very easy to implement, and go with it. The second model is V model. Does somebody heard about that? So how does it work? Our project starts here, and we're going through all the requirements. So here we write what should be done. After that, we are coding, and then we would going and testing every single step according to our requirements. Can somebody tell me what's the difference between verification and validation? Yeah.
I guess verification is that actually can work, and validation is that the client really wants that way.
So the easiest way to memorize the difference is basically validation is we are checking, are we doing thing right? And verification is, are we doing even right thing or not? Validation, we can just go through the requirements and check like, okay, it's done. And through the verification, we're checking, are we actually done the same project as we written down or not? For example, does our final project look like a car or something else? It's basically like that. The form of incremental is a spiral model. So as we were talking about example with the car, on every single step, we're starting somewhere here. We going through the determining our objectives, identifying risks, implementing testing, and here we have a working product which can be already delivered, and we should stop our spiral as soon as our client satisfied with our prototype, and we hit our definition of done, so we accomplish all the things which were planned. As huge advantage of this is we have we can analyze our risks better than in incremental or flexible approaches, because on every single stage we have MVP ready to use, and if anything goes wrong on the next iteration, we always can circle back to something which exactly 100% was working. And the disadvantages of this approach is it's very expensive, because we cannot afford ourselves to not deliver on the end of the spiral. So our prototype should be always finalized, and sometimes somewhere here, when we are looking at our risks before delivering the prototype, we can see, okay, it doesn't work, and now we need to somehow fix that. And here the legacy is born. So legacy code is some code which was written in very hot situation with the time. For example, our deadline is tomorrow. Today, our prototype is not working. We can fix it with like this piece of duct tape on our code. And at some point, our developers can never return to that. They can return, but developers don't like to look back. And we are moving to the flexible methodologies. And I want you to see this video about how this Scrum works. I hope this does it. So as it was said, the most advantage of Scrum is basically constant communication inside the team. And because our team is cross-functional, on every single daily meeting, you can complain to your colleagues about some struggles that you're having with the tasks and ask for some help and some, for example, advices on how to do. Maybe some of the colleagues working on something really connected to you, and you can figure out the solution together. And also, if something going not according to our sprint plan, we can say, okay, we probably with a high chance, like 90%, cannot deliver this functionality till the end of sprint. And our management is already prepared for that. Some tasks can be transferred to another sprint, and we know that we won't meet our deadline, so we can take some other actions about that. One more time, how the team should look like, and what's the main thing about. As it was told in the video, the product owner is somebody who has a vision more than just current tasks, but for a whole project, and who can explain what the Scrum Master is doing. Yes?
Make that the team follows the Scrum rules and the methodology.
But for example, can you give an example how the Scrum Master, what he's doing, like basic day of Scrum Master. Because from the side of developers, it's some guy who's coming to the meeting and say like, oh, everything good? Okay, bye. And then appears only next day. What the Scrum Master is actually doing.
He helps, for example, the code owner to, when he has some doubts or he's not sure about the priority of the task, and he is like the not the leader, but someone who you could go when you are not sure about how you're leading the group in case of the group point.
Yes, and also the Scrum Master should. I'm sorry, is it an answer for the question or it's an unmuted mic? Okay. Also, the task of a Scrum Master is to protect the small team from the stakeholder who sometimes want to put more tasks when our capacity of software engineers. Sometimes the Scrum Master failed that responsibility because he also wants to deliver fast. So sometimes like, okay, we can let this task to sprint, but in perfect Scrum, it should be impossible. So our team shouldn't be overworked or overwhelmed with the amount of tasks. And this is the responsibility of Scrum Master. And also the Scrum Master should facilitate basically all our meetings and not let the software engineers to fight with each other because of some functionality. And in my work experience, it was the situation when on architecture planning meeting, 2 architects was super close to have a virtual fight. And the Scrum Master was saying, okay, calm down, we can discuss it later. We can think about that, but please not now. So the Scrum Master is basically not a manager, but maybe it's not a polite word, but it's babysitter for the software engineers. So what is it? What's a Kanban? Kanban is also a methodology of flexible software, flexible approach. And this is the methodology which also use the Scrum board. We have, as shown in a picture, to do column with tasks. We can also indicate which tasks is in progress, which tasks here it's mentioned as wait, or it also can be named as like in testing stage. So it's basically some tasks which are not in progress, but they were started some time ago, and now they are either waiting for some other tasks or the software testing team are doing something, and then they are moving to the done. What's the key difference with the Scrum? Is in Scrum, we determine our sprint with the tasks in the beginning in the sprint planning meeting. And in Kanban, our sprint have a limited amount of tasks which can be done, and we can add or remove some tasks during the sprint. So every single developer have some capacity. For example, I'm as an employee of a team of 5 can have only 5 tasks during the sprint. And it doesn't matter in the beginning, maybe I have had only 1. And after that, some testament were performed, some new bugs are released. And now I'm having urgent tickets to take in work. And these tickets can be added not during the sprint planning meeting, but during our work. So let's sum up what's the difference between Scrum and Kanban. I've came out with some analogy. For example, Scrum, it's like a bus. Our tasks is a people in the bus. They can be uploaded only on the bus stop and get released only on a fixed point, on a fixed bus stop. So in the end of the sprint, they going out and going in as a groups. And the Kanban looks more like a huge taxi when the passengers as a tasks can be added and removed from the sprint as a bus at any point they like, but this taxi still have the fixed capacity of the passengers inside. So in a Scrum, all the roles are specially allocated. We have stakeholder, project owner, we have the team, we had a Scrum Master. In a Kanban, our roles can be not allocated. For example, if we are working as a team of software engineers, our team lead or our senior engineer can also be a project owner and the Scrum Master in the same person. These roles are not allocated, and these roles cannot exist basically. Yes. Also in the Scrum, our sprints are fixed by the time. In Kanban, they can be fixed. They can be any length you like. For example, at some point in the end of the year, you need to deliver something, but your sprint, it would be only day 3 of sprint. For Scrum, it's not possible. For a Kanban, why not? There's also a methodology called Scrumban. It's basically we take in everything that we like from Scrum, everything what we like from Kanban, and adopt it as we prefer. Later, you can take a look at this table more in details. But basically, we're using Scrum processes as fixed sprints and meetings and Kanban visualization. So we are adding as many tasks as our capacities. So now let's discuss about appropriation of these methodologies in data science. And for example, we have a task. We have an online store where is some assistants, virtual assistants, and we want to increase our number of sales in this store by introducing some form of AI algorithm to do something with customers, to maybe classify them or answer the questions. And which approach you see to achieve these tasks? How many AI methods we can use here? There's no wrong answers, just give any ideas that you have. Yes?
So we could start with simple logistic regression. Deep learning, natural language processing, and then combining. For example, the feedback, which will probably be text. You can use natural language processing for that or embeddings, and feed it back to whatever system does.
Yes. So you mentioned, I lost count, but more than 4 approaches to this task. And as an industrial project, we have let's think that we have logical regression, neural networks, and for example, some simple classification and clusterization. For every single approach, how we would determine that this approach work or fail? We have some metrics, but can we know in the beginning, before the implementation of any approach, would it fail or not? No, we cannot. And in this situation, how to deal with, for example, with flexible methodology, we have a ticket for every single method we can implement. And for example, we tried logical regression and we don't satisfied with our metrics. Can we put this ticket to done if we have accuracy of 0.25? Is it done? No, but in flexible methodology, we cannot put this task forever in progress or wait, but it's also not done, and our customer paying us for doing something. So how we can manage our project then? For that, there is a lean data science or lean DS approach, which based on hypotheses, which we are making with our customer. And Firstly, we are formulate our hypothesis. For example, we would try this approach. We would try linear regression to achieve this metrics. And after that, we actually implementing experiment and validate our result. And using Kanban board, we can put our task into done, but our tasks were formulated not just implement logical regression, but this formulated as a hypothesis. And if our hypothesis doesn't work out and were not proven, it's still done. So we don't have this legal trouble with closing the tickets which were not actually done. So how the lean DS hypothesis look like? There's 3 types of hypothesis. First of all is product hypothesis. This is a statement which we are formulating with our customer. So our management sit with a customer and talking like not in the programming words, but in the word of the customer. For example, we believe that we will solve some problem for some audience. And to do that, we will make some change, and we will be right if we get some metric. And after formulating these sets of hypotheses, we are bringing this to our analytics, and they formulate the data hypothesis or method hypothesis. Here, here's already more software engineering stuff going on, and we are talking about which method we can try and which metric we think we can achieve, or how we can manipulate our data to achieve better results. And now let's try to formulate together the hypothesis for our task. If we would take into consideration that we have some on-site assistants which can personalize and answer some questions. Okay, who want to try? So now we just need to fill this brackets. We will solve which problem, for whom, and what we would do. Which problem? Yes, which problem we see here?
Identify customers that mostly buy our things, and for the customers we want to identify they're not interested in our product. So if we know who's not interested, for the customers we can give them more attention. So we want to identify a target group in the audience. So we want to solve a key audience for the audience for our best customers. To do that, we will analyze their data. We will be right if we get an accuracy of 60%.
Mostly correct, but you told that we would achieve some accuracy. And if you are thinking as a customer, you don't know about accuracy, nothing. You know only about your money. So the best metrics here can be we will reduce, even improve the answer of recommending system by some certain percent, or we would reduce our costs. So our hypothesis can look like this. So we reduce our costs for some agents, like is it on-site consultants or people who is serving the mass segment. So they are serving our customer people. To do this, we will automatically categorize customers. For example, to the category who would most likely buy something or who are not interested in it. We will be right if we increase the number of customers served by the engine who were satisfied by the agent's response by 10%. So, based on this product hypothesis, now we need to split it up to the tasks for the programmers, because if you as a software engineer were given the task formulated like this, how frustrated you would look like. And we need to formulate actual hypothesis for data science. And the data science hypothesis should be corresponding with two main things. First of all, our data hypothesis should be correspondent with the product hypothesis. So if we are thinking about clusterization of users, our data hypothesis also should somehow be related to that. We are not allowed to formulate that we will not, now we don't like to clusterize our users. Now we want to use some generative transformers for speech analytics, stuff like that. And the second main thing is that our hypothesis should be atomic. That means atomic. That means we can only say, okay, we would change the method or we would change the data. We cannot change the method and the data simultaneously. So as an example of data science hypothesis can be, we believe that on clustered users questions and agent response, we can build a linear classification model for hint selection, and that will allow us to obtain a top 5 accuracy of at least 50%. So here we introducing that we will use linear classification model, and we say, okay, and now it's a good example of the task which can be done by a software engineer. So you receive like this three sentences, and now you can go and like, okay, I need to implement a linear classification model. I need 2 weeks for that, and I need to achieve top 5 accuracy, at least 50%. Now everything is clear for a software engineer, mostly clear, and he can go and implement. And now we would talk about some side projects and some interesting methodologies which are not that commonly used in the field of actual industry, but mostly used by startups, small companies, and can be implemented by you as students because it works perfectly in a small teams and when you have a lot of time. And the main approach is an extreme programming. Extreme programming looks like the combination of all best practices which you ever heard before. And it's basically, if we have an analogy with, for example, driving the car, extreme programming don't care about the destination, it cares only about process. So if we're talking about software engineering, we can think, okay, what if our project don't have a deadline? What would you do if your project would be infinite, if you would have infinite amount of time? Would your code be different from the code you're writing the night before the deadline? Basically, you would maybe cover everything with tests. You would frequently refactor your code. You would, without any doubts, delete the something which you are not using anymore. You would refactor soon. You would try to keep everything optimal and solid. And the key thing of this approach is to exactly do something like this. And this approach is basically tries to say, okay, we don't need any management. We need only our developers to talk with each other, to write a good, clean code, and to communicate with our customer on what they actually want or not. And by giving constant feedback, for example, we wrote something, the test failed, we have instant feedback, and we can rewrite it at the same place. This approach has a lot of advantages and disadvantages. I think all of you can imagine how life would be perfect if our project won't have a deadline. But about disadvantages of this project, it's basically we need to 24/7 available customer on our side. So if some of our developers work during the night, They need constant feedback from the customer at that exact moment. I guess it's not really doable. Also here, as it was stated, we are focusing on the process and not on the result. And our project can be infinite in that point because we don't have a definition of done. We are focusing on the process and not on the result. So we can try to achieve perfection, but perfection is never achievable. And also, because of providing constant feedback, we need to have a lot of meetings with software engineers. And first of all, software engineers would hate you because of that. They don't like meetings. And the second thing, it's very expensive because meeting is an hour. Software engineer makes certain amount of money an hour. So we just wasted a lot of money from our projects. And also, you can imagine how chaotic would be the project if it would be a company-sized project. It would work with, for example, your project in university. It would work in a small startup. But if we would think that Google implement this, it would be chaos. Extreme programming can be used by some of sub-frameworks of these frameworks. It's pair programming. It's basically when we are coding in pairs. And here is the two key approaches to do that. It's basically lead and navigator. So navigator is somebody who determines where we need to go. And the lead just implements after this person who creates the ideas. And the second methodology approach to that pair programming is ping pong. So it can be test-driven development as TDD. So one person writes tests and the second person writes code to go through these tests. Second approach for ping pong can be collaborative refactoring. So one person writes code, other person rewrites. And yes, we can also do it not test-driven development, but just development. So one person writes code, other person writes tests, and they pretty happy about that. Can somebody name some advantages of pair programming? Yes?
See your own mistake. When you work on a code non-stop, stop seeing your own mistake, and you get a little bit of input from the other person on how you could probably make it faster. And sometimes when another person writes a test, they find out where you will forget about something totally. So it can be very helpful to also switch these roles. When one person writes a test, and then after a while they switch and the other person writes a test. And then they can always have fresh ideas.
That's right. And also something wasn't mentioned is the bus factor. Does anybody know what this term is? Yes.
When people need to be hit by the bus until you're not operational anymore.
Yes. This term was introduced in the beginning of 2000s when the creator of the Python programming language was asked what's going to happen with the Python if you would exit this building and get hit by a bus. So yeah, the bus factor is basically we trying to help ourselves to not struggle if one person would take vacation, would get not instantly sick, but unplanned leave, and we should know about what's going to happen to the project. And basically some disadvantages of this approach is resource intake. We are occupied 2 people instead of 1. And this approach not actually suitable for research tasks, because if you're doing research and development in data science, it's basically just work for one person. You cannot transfer some of your thoughts to other person without communicating. And when you were just telling like, okay, start from here, it's a lot of time delay. And also the third disadvantage, if you're long working with one person, it's really hard to get it up to beginning from the speech and just appearance of other person or to the code style. Second approach of extreme programming is test-driven development. It's basically when you firstly write a test for your functionality and then write code to pass these tests. So it looks like something which you would write software requirements and then develop, but on smaller level. Here, this approach not that widely adopted because basically when you're thinking about one module, you can write tests and then can implement it. But when you are thinking in a scale of whole system, it would be kind of hard to build an architecture based only on testing. And do you think this approach can be adopted by now we using artificial intelligence to generate tests for existing code? Does this approach would help us to say to the AI, hey, I have this set of tests, can you generate a code for me? Wouldn't that be easier or not? I guess it's one of the topics for the final presentation.
Yeah, think about it. Because with test-driven development, you write code and you ask the AI to write tests for you, which is good, but maybe you can rather write a test yourself as a specification and then the algorithm is generated for you. Maybe that's the future.
So what we have as a summary of our lecture is that there's a lot of methodologies and you should try, not try to go with just the most popular one. You should try to start with the most simple one and then upgrade until the point that you and your team is satisfied with the result. And also you don't have to blindly follow the instruction on how to do something. For example, for Agile or for Scrum, there's tons of books how to build perfect Scrum team. But if it doesn't work for you, don't do that because you need to adapt to your own needs. And also try to discuss any approach with your team members. And then I have set of some topics for, can be the final presentation. You can try to discuss about less and safe. This is a Scrum and Agile methodologies, but for big companies. That means you're not talking about 5 people in a team. You're trying to build a huge Agile company of thousands of people. Also, some tools for deploying your AI models on servers as Kubernetes and Jenkins. You can try to discuss some AI-based code writing helpers and also look what is Ansible. And this is thing to manage your data between your experiments with data science. Maybe it's not for final presentation, but you can adopt it for your educational projects. Also, I would be happy to answer any of your questions, and if you would have them further, you can contact me by email or by LinkedIn.
Any questions? Yeah, thank you very much, Katja. I would continue then. Yeah, thank you very much, Katja, for your guest lecture. So you see, she attended this course last year. This year, she's giving the guest lecture, so you can get promoted quite quickly. We also talked about consulting before, and this is actually the book I wanted to recommend. It's called $1 Million Consulting by Alan Weiss. He wrote plenty of other books, if I recall correctly. And the book provides quite a good introduction to consulting, not necessarily AI consulting, but AI consulting in general. So take a look at it. Maybe the book provides some helpful lessons for you in case you want to go into the consulting business. Then we had last looked into this machine learning canvas. So this is something we discussed it in detail, but just again, why is it important? When you start some machine learning project, take a look at it in the beginning. It can help you on one page. You can take the key notes or the key questions and then investigate further. And I would personally always start with the value proposition, whether you're actually adding any value at all. I also wrote a book a few years ago. So this is not a sales pitch for the book. I know these books are insanely expensive if you buy them with Springer, and the authors get very little. So if you buy this book, I don't know, for 70 euros, so a friend of mine and I, we edited it. We get maybe €1, but we need to split this. I get 50 cents, he gets 50 cents. And then we still need to tax this. So books are great for fame and spreading your thoughts, or can be helpful if you do consulting. You can say I also wrote a book, but most authors don't earn well from the books. There are other ways. If you ever want to publish your own book, there are other publishers. You can do self-publishing, and this may help to increase your return. But if your book is not with a well-known publisher, probably this also hurts reputation. And they take advantage of this, obviously. And then these books are expensive. Most people will struggle to pay that much. If you can make a book obviously open access, then the PDF is publicly available. And because we're just finishing a new book with Springer. Do you have any clue how much you need to pay to Springer if you want your own book, so for which you're writing a content, to be open access? So what Springer always offers is for free. They do the productions, or they turn your manuscript into the final book. They don't really look much at content, just some language, but minor. And they format it all and make sure it fits in their template. And then the book is printed on demand. So if someone orders the book, they print this. So costs for them are not that much. If you want to buy the PDF, you still need to pay. And now guess how much you as the author would need to pay if you want your book to be open access. So the PDF would be free of charge on the Springer website. €13,700. We just looked it up because someone asked me a few days ago for our new book. So that's beyond budget here at the university. But there's one chapter in here, and we will look at the chapter. The chapter is also available via Nextcloud to our students, because we're allowed to share internally like one of the chapters or so as a PDF. And I wrote this book chapter a few years ago. It's called Unlocking the Power of AI for Your Business. And I share some best practices, what you need to do in order to commercialize AI. Just in essence, first of all, as a definition, what AI actually is. That's discussed here. Peter Norvig said in a video something like AI means, to him as a definition, AI is the science of knowing what to do when you don't know what to do. So that's how Peter Norvig would say this in one sentence. As a motivation, in the beginning of this chapter, I talk about AI innovation in China and why this should force us to be more innovative. But we'll talk about this tomorrow, because I have some insights on China in one of the following chapters. Then there is a brief overview about the history of AI and what machine learning is, but you all know this, and the 3 pillars of machine learning: supervised, unsupervised, reinforcement. Because this book chapter is meant like as a quick intro to executives, decision makers, what AI is and what they need to do in order that they build the right processes and organization to make money out of it. And the interesting thing is the question, who should be in charge of AI? We've discussed this briefly before, and I said you could have some sort of AI competence center. You can do that, but who should be heading that competence center? Sometimes there's not just an AI competence center, but maybe some digitalization center. And a term that has been used for a while now for this person who runs this is a CDO, a Chief Digital Officer. And who should that person be reporting to? What companies started initially was that you put this CDO within the IT department of a company. Now, if you work in a large corporate, you will notice that your internal IT is typically not that innovative. And there are reasons for this, because their main task is to guarantee stability, reliability, that it all works, because you want your emails and phone and servers to work, because if they are down, this will be expensive. So reliability comes first, which comes at a certain cost that innovation is more difficult. And I don't know, maybe some 8 to 10 years ago, a lot of big corporate in Germany, they tried to hire CDOs. They tried to hire people from Google, for example, as a chief digital officer in some big company. And that person was then with his or her team in the IT department and had to report to the CIO, the chief information officer. And after 2 years, most of these CDOs were gone, because they felt they did not have that kind of freedom that was needed to innovate. I've seen this myself too. So when I started working at Kronos, company at that time with 15,000 employees, when I started building up the AI competence center, I also noticed we got laptops from the IT department, but we couldn't install anything on them. They didn't want virtual machines because they were scared of that too. So we struggled setting up our Python environments. And because for every Python package we wanted to install, we would need a new code. So this would never finish, especially if you have a whole team of people. And then I went to the head of IT, the chief information officer, and told him I need 10 laptops without an operating system. Just off the record, we get 10 laptops and we take care of them ourselves, because my team, I was based in the corporate research and development. And there we had some development networks and this kind of stuff. And then we had these laptops and we just installed Linux on them, because the corporate laptops were Windows anyway, not too great for development in AI. And we set up these Linux laptops and did the R&D on our own. So this worked quite well, but it creates new problems like IT security, access to internal systems, because with these laptops, you could not connect to the actual corporate network, but only to, say, a developer network or something. But there were certain ways to access the data. That was not a huge issue, but we ran into cybersecurity issues. Like one of our students, he then we had an intern, he actually started connecting his Android phone to the developer network and infected the whole developer network with some viruses, which wasn't great at all. So we've seen all of this. And it's still a trade-off for companies. Like, how can they guarantee an IT stability on the one hand, on the other hand, how can they actually create innovation? Some time has passed. Now companies have made more progress with maybe virtual environments or other infrastructure in which developers can develop more freely, or they have a much bigger development network or development environment that is administered by IT. Ours was not. And I'm curious, how does this work in the companies where you are doing your internship? Anyone wants to share some stories? How can you access the latest Python frameworks, libraries, and tools on your corporate laptop within the existing infrastructure? Anyone wants to share anything? Yeah. Yeah, not possible. So what kind of development environment do you have?
They have to go through the internal process. Then they have an internal marketplace where we can download the software and then we can download our packages. And you can only download those. There were in the past people who did download from the open internet, but then we got shunned by the, security.
Yeah.
Similar things, but
Okay, so I'll just repeat in case the mic isn't as strong. In that company, you have an approved Python environment, but it's never up to date, and you cannot easily add new packages, I guess. Yeah, so it's a closed environment and only approved and certified, but not up to date. Same here. One student writes, they have some installation manager where you can download approved software. Technically, every installation outside this has to be done by IT. One writes they use some container setups and everyone has their environments as the same environment since they have the same container setup. Okay, yeah. As you see, that is challenging. If you are in a small startup, maybe all of that is much easier because no one cares about IT security too much and you can just set up whatever you want, but it can lead to chaos. I'm personally super happy I'm a professor here, so I have full control over my laptop. When I got this university laptop, I didn't want IT to pre-install anything. I just said, I'll take it as it comes from Apple and I'll set it up on my own, so I have full control over it. But I'm also not much connected here to the internal infrastructure. I'm just connected to emails and Primus and Nextcloud and iLearn, and I think that's it pretty much. For the colleagues who work here in our administration, it's more difficult. Obviously, they get some setup environment, but they also don't need the freedoms as the professors need to have the tools to work. So that's what I did at Kronos. We just got some laptops on our own and ran them on our own. And was at that time, at least, they didn't have like this installation manager of some improved environment. Now, I guess they have, but it was simply the fastest thing I could do to deliver because I didn't want to wait half a year. For some people, it seems perfectly fine in big corporate just to wait 6 months and nothing happens. But I want to make sure we build lots of interesting AI use cases in the first quarter, and we don't just wait for half a year for something to happen. So ideally, such a chief digital officer needs some freedom. Some companies chose that it's a separate entity. And then sometimes you see something like this digital department would start a new project. They would quickly develop new services and products. But finally, this has to be moved into production to run reliably and be integrated in the existing infrastructure. That's where the IT department would come into play. And then if development is continued, the digital department would contribute again. So this is sometimes some sort of collaboration you will see, but you have two managers at the same level. So this can also lead to chaos or jealousy and competition and whatever. Yeah. And here's also the next best practice around this in-house AI competence center. This is, so I said AI is important for everyone up from the CEO down to the factory worker. Everyone needs to have some understanding, but you still need to put the expert somewhere. And that's why oftentimes like you would see that AI not only concerns a certain department, but a company as a whole. And then such a competence center can be helpful that maybe sets the overall strategy and direction, but works closely together with the other business units and helps them, provides training, helps them with use cases, but the other business units would also build up competencies. And that's what we did. And it overall, I think, worked quite well because not everyone in such an AI competence center knows all the domain issues or domain knowledge you need to know in order for AI to succeed in a certain business unit. There you need the domain experts, but maybe they have some computer scientists, maybe some engineers. And if they get some training on how to build AI, maybe they can do a lot of the work on their own, and they can still get support from the in-house AI competence center. And the competence center can work on some of its own projects. And there are different roles. We mentioned this before, like data scientists, data engineers, software engineers. Here we call the data engineers more data architects. That's also a term that is sometimes circulating. But all these terms mean something totally different throughout the different companies. And there's also something we saw. I think it's one of the students who mentioned this in the comments earlier today, how much time you need to spend on which tasks. So when you study AI here in your first 4 semesters, you learn how to build AI models or machine learning algorithms and how to optimize them. And you think this is probably what you spend most of the time here at university, and this is what most of the literature is about. And this would be most of what you're working on in reality. But in fact, this is maybe just a smaller part of your work because there are lots of other things. Before you build these models, you need to collect data, you need to do an exploratory data analysis, data cleansing. You need some infrastructure where this runs, because typically you cannot just run this on your laptop. And eventually you need to integrate your algorithms in an existing environment. And probably even earlier, you need to think about the KPIs, the use cases, and all of this. And all of that takes a lot of time. And just building the ML is still something that takes time and is challenging, but it's not probably the biggest part of the work. There are some data scientists reporting 80% of the time is spent on just aggregating data, cleansing the data, and then training the model is maybe some AutoML work largely. And AutoML is really cool. I mean, it will not give you the optimal model, but in a short time, it will give you a very good one probably. And you can take that one, you're fine, or you still further improve it. But you should be using such stuff like AutoML. Otherwise, you have a problem because otherwise you're just too expensive with too little impact. So don't underestimate that your work as a data scientist includes more tasks than what you do here in most of the courses. And that's also one of the reasons why we do this innovation management for AI course. So we also look at some of the business problems around it and that you're able to reflect all of this. And it's not just sitting there using scikit-learn or TensorFlow or whatever all day long. Then when I worked in mechanical engineering, for example, I noticed for them, it was quite uncommon to use open source. So they were just used to buying very expensive software from Siemens or ABB. So I also pushed for a lot of open source. Now in the last few years, this has probably also advanced, but at least traditional, like classic companies, construction, engineering, they're used to buying software. They're not used to getting software for free. And I think it's a beauty that we have so much really good open source AI tools available because we can use them here at university. And if companies use them too, you already know how to use them. In the past, if companies used some closed source commercial AI software or whatever other software, they first of all had to send you for some training in the first weeks when you start working there, which is super expensive. And like that kind of training is not necessary anymore. We've talked about this table and the works, and I've already said that everyone in a company needs some understanding about digitalization and AI, from the CEO down to the factory workers. And this is what this book chapter largely covers, some best practices, and there are some other things about AI and the singularity. It's just, to conclude this for the decision makers, but we'll talk about this in the next chapter again. Now, feel free to read the book chapter. It's available to you, and it's not a sales pitch since you will find a PDF in our Nextcloud directory. What I also came across is, and I've added it this year to the course, is the so-called data science analysis rubric. This is something proposed in the Data Science in Context book by Peter Norvig. And what it covers is a couple of initial points to think about when you start your data science project. And it covers these different criteria, and I think we'll just look at them with an example. So, for example, if you want to build an AI that can do route finding or find out the traffic speed based from street signs, the question is, do you have tractable data? Yes or no? Is your technical approach feasible? Yes or no? So if you want to build level 5 fully autonomous cars, it's unclear if this is feasible anytime soon. Then if there are any risks, maybe whatever risks that could happen, is explainable AI important or not? For some things, yes. For some, probably not. Are the challenges clearly defined, or sorry, are the objectives clearly defined? How can you tolerate failures? And then there's this term here, ELSI, which refers to ethical, legal, societal issues or considerations. So are there ethical issues? Are there legal issues, like any kind of regulation you may need to look at? Are there societal issues, maybe also sustainability issues? And that's in short, ELSI. Probably for traffic speed, not many. For level 5 autonomous, fully autonomous cars, there are more of these challenges because humans may get hurt. So this is not like a competitor or something like this to the canvas. I think it can be more of an extension to the canvas because I think both address two different needs. But I would personally always start with this canvas, and maybe for some of the extra questions, personally look at this data science analysis rubric. And there are some examples here, and you can find this book also on the internet or buy it. If you are looking for topics for your seminar presentation, Katja mentioned some possible topics already at the end of her presentation, which I think is excellent. There's also a journal paper that I've also uploaded in Nextcloud. It's called AI and Business Value, a literature review, which discusses in detail how AI adds business values, cites lots of studies. Maybe there's also something that you could find helpful for your seminar presentation. So we have finished now the AI transformation of a company part. Tomorrow, there are 2 more guest lectures. And we're not done for today, so don't look at your watches yet. We will still continue for a little bit. Tomorrow, we have 2 visitors. One will be here on site, and he will share some of the AI projects they are doing in their company and around consulting or their IT vendor. You will see this tomorrow, and he will explain some of the challenges they are facing and how they have solved it. And then we'll have another guest speaker. He will connect via Zoom for a smaller contribution, and he will explain us. He has a use case he needs solved very quickly. And in fact, it's a super interesting use case. And he's just looking for a student who wants to work with him. And he will present this tomorrow briefly. So if you're still looking for an internship, a thesis, or a working student contract to make some pocket money, you'll see more about this tomorrow, because that guy I met, the guy who will give the guest lecture tomorrow, I know him for years, and we just met on Tuesday for a coffee and had this very spontaneous idea. And I said, well, just present it on Saturday, and you will see a very interesting challenge where AI could help. Yeah, that's the AI transformation part. And now it all looks clear. We have like process models, how we can continue. I've told you how we can identify AI use cases, how we can describe all of this when AI doesn't make sense. So it all looks super simple to achieve maybe a 90% success rate. But there are challenges, many challenges. And in the past, I had one chapter here for contemporary challenges. And this one was quite small. And I noticed now every year it keeps growing. So this is, I think, the 5th time I'm teaching this course, the 4th or 5th time. And every year that part keeps growing. And especially the legal concerns are growing. And that's why I had to move this even into a separate chapter. Concretely, I'll share some insights of what I saw in Davos this year when I was there in January. And I'll share some photos and some impressions. Then I'll talk about all these worries about the end of the world caused by AI. And we'll analyze this. A lot of these fears seem to be related to the singularity, so that point in time when AI become as smart as humans. We'll look into assurance, explainable AI, ethical concerns, AI innovation in China. I'll share some of my insights from China, where I spend quite a lot of time every year, as well as we'll discuss how AI impacts the jobs market. And all of these challenges are right now there, plus the legal ones. The legal ones is even more regulation, copyrights, and even military applications. So, but the legal stuff I've moved into a separate chapter. Otherwise, the contemporary challenges would be the far biggest chapter. So I was this year in Davos, and every year in Davos, there's the annual meeting of the World Economic Forum. And there's every year one big topic. And this year it was AI. And I had never been to Davos before. And I wondered, how can that town actually be entered when you have all these heads of government, heads of state, and God knows who is there. Entering by car is theoretically possible, but there's just a lot of traffic jams, so this doesn't work. The easiest way is to enter by train, and you can just get in by train. And there are all sorts of super interesting and famous people sitting next to you in the train, because they somehow also need to get into Davos, and the car is difficult. And then at every bridge you can see on your way to Davos, at every bridge, the closer you get to Davos is secured by military and all of this. And they have, anti-missile defense and all of this stuff set up in Davos, because they bring in, hundreds of heads of state, heads of government. So it's just surreal. And you walk through the city or town and suddenly maybe some king walks next to you or something. So it's a surreal experience, but you can get in by train, but it's just super crowded, everything. Because Davos is pretty small and they put in all these people for this big conference. So I found this super interesting. If you want to attend the actual annual meeting event organized by Mr. Schwab, then you can pay an enormous amount of money for your ticket. But there are side events. And there are hundreds of side events in Davos during that week. And there was the AI house as a separate building only doing AI. And it's interesting, these venues, it's just usually buildings where there are shops, and these shops move out for 3 weeks. So 1 week move out, and 1 week Davos, and then 1 week move back. And the owners of this real estate, they earn more from renting this out for 1 to 3 weeks than in the whole year. And if you want to stay in Davos, even if you want a simple hotel room, and even if you still get one because they're empty, you need to expect to pay 5,000 euros plus per night. So that's not possible as a professor. So we stayed in an Airbnb 1 hour away, but we could just get in by train. So this is perfectly fine. And then I attended this AI house, but there are hundreds of other venues from companies, from whatever. So it's super interesting. In the AI house, there was 1 week of events, speeches. I also organized a session together with a friend from CERN, where I worked in the past, about AI and education. And in that AI house, we then did our session on AI and education. There were lots of other people there, like ministers, executives, researchers. So it was really cool to connect. Obviously, not everyone there is an AI expert, but it just brings together decision makers. So I found this super interesting. And there are all sorts of people there that you know from the news. For example, I had a chat with Theresa May, the former Prime Minister of the UK. She was there. Was very interested in AI, and 2 of the princesses of the royal family joined her. Concretely, the 2 daughters of Prince Andrew were there. So all sorts of interesting people during this week. And I found the week in Davos super interesting, just to connect to new people, researchers, people from industry. And you see everyone is interested in AI. And AI is not just changing single jobs or single industries. AI has started to disrupt everything. And that's why I think you're at the forefront of earning the big bucks in a few years with your AI education here, because everyone now needs very talented AI experts. I also met Andrew Ng. So this is something I was super happy about. Because I started in AI because of his course that he made publicly available. So in early 2012 or late 2011, something like this, he had his Stanford class, and then he made the machine learning class publicly available and changed it a bit. And this is what finally created the platform Coursera, because Coursera was created by 1 or 2 courses initially that were there. There was another course from Peter Norvig and Sebastian Thrun on AI and robotics. And that eventually was one of the beginnings of Udacity, a different course or a different platform. And I met Andrew Ng in Davos. So I was super excited and told him, yeah, thanks to your machine learning course from Stanford that you made available to everyone at the end of my undergrad, I got super interested in AI. And without that kind of course, I may have not picked AI as my career. So it was really cool to meet that guy. I also met Stuart Russell. I mentioned before that I talked with him in Davos because he's the famous author together with Norvig for the AI, a modern approach. And we discussed how you could actually define AI or how you could maybe not define it. So you see, Davos brings together lots of interesting people. And it was just super exciting. And I'm currently in discussions, if I go there in January again. AI will probably not be the big topic in a row, but different topics. But there's probably some AI side event where I may be going, but this is still to be finalized in the next few weeks. What I noticed in Davos, there's not just excitement, there's also warnings. And what I noticed is you have people like Elon Musk and 1,000 other experts. They call for a 6-month moratorium, or they called last year for a moratorium around AI. Concretely, at the end of March last year, to me, this looked like an early April's Fool. And what they said was the world was going to end because of AI, and this could only be stopped if high-end AI R&D was paused worldwide for 6 months. Stuart Russell, so this guy here is also among the 1,000 signatories. I feel Stuart Russell has turned quite negative about AI, because what he said is he wrote all these books about AI, and suddenly AI made lots of progress, and he's not that happy with that progress. And he's also concerned that AI could harm us. And I also tried to discuss some improvements with him or some issues that we could address, but he doesn't seem to be interested in that either. So he's maybe more interested in warnings. And I saw Stuart Russell again just in September in South Korea at a conference about military applications of AI. I'll talk about this tomorrow. And he's obviously concerned, like many people. And I said, well, I have these and these solutions, but he's also not interested in the solutions somehow. And this actually applies to a lot of those 1,000 people, I feel, who have signed that. And I don't think that AI would end the world. And even if there was some risk, we would need to address them and solve it and not just wait for 6 months. Because just waiting doesn't change anything, and others will not follow this. So, and there are others warning about it, in particular Elon Musk. And what I noticed is just a few weeks after he had asked for this moratorium, he actually announced a major AI initiative for his companies. So that also doesn't make any sense to me. And what I feel is maybe negative news spread better than positive news. There's also Sam Altman, the CEO of OpenAI. Even he warns that ChatGPT could end the world. And I think, well, Sam, just shut down your ChatGPT, you know. But I think they like the negative news because it somehow accelerates their popularity. And it also helps them to control regulation. Because if big tech warns about their own products, there's a situation that we got in is that there is regulation, but big tech can comply more easily than a smaller competitor. And big tech has largely contributed to that regulation. So in fact, they don't care about potential victims, they rather care about themselves. And we've seen the same with the GDPR, the data protection regulation in the EU. It actually supports big tech because it's just so complex and smaller competitors can hardly comply or pay for this. So this, as you can see here, is Mr. Altman, Sam Altman is warning about a risk of extinction from new technology. But then they actually actively work on these technologies. So it's confusing. And the politicians are obviously following this. So last year, there was the AI Safety Summit in the United Kingdom, in which they addressed lots of fears, but not much solutions, actually. And I think sometimes really absurd risks, like Kamala Harris was at that summit, the vice president of the United States, and she said something that it's unacceptable to her that an AI kicks elderly and sick out of their health insurance plan. So that an AI would decide that you're not profitable and you get kicked out. But she's only concerned about this if an AI does that. And in the US, this is the reality. But first of all, it's humans who have made these decisions for a long time. And to me, the much bigger concern is that you can kick sick and elderly people from a health insurance plan because they're not profitable anymore. And whether a human makes a decision or an AI is something I just don't care about. The problem is that you can kick such people off your health insurance plan, something that is not possible here with our public health insurance system. And I think that's something very important. But then, yeah, AI is the problem because the AI could do that. To me, the problem is much more generic, that it's actually possible to do that. And whether a human or an AI does it, I don't really care. And maybe the AI can, even if you used an AI to do this, maybe the AI would do it in a more fair way than humans, because the AI may not have a gut feeling. So these are some of the things I'm concerned and that I also saw in Davos, but often it's just the AI's fault and they don't think about maybe more general problems that could be addressed. And what I also notice is that it seems to be okay when humans make mistakes, but it seems to be unacceptable when an AI makes mistakes. That's something that I also feel a lot from these political debates. And yes, machines make mistakes. We use statistics largely here. So uncertainty is part of the equation, but humans make mistakes too. And I think if we have double standards, say we have standards for humans and we have much higher standards for the AI, this creates lots of problems in the discussion and in compliance. If we just required the same standards for humans and machines, probably a lot of these concerns that we have right now and compliance issues would just disappear, because there are mistakes. Yes, mistakes are made, and so they are made by machines. And that's why we also have product compliance laws, something I will talk about in the next chapter, because there are product liability laws for a very good reason, but that doesn't mean that you're not allowed to have, or it doesn't mean that you're required to have absolute zero mistake. You can reduce the mistake to a certain degree, or the error, and then product compliance is okay under certain conditions. And everyone now seems to, and first of all, these people like Altman, whatever, I often call them the prophets of AI doom, because they sort of claim the end is near. So I came up with this term, the prophets of AI doom. And then everyone seems to be an expert on daily TV. And the people that get invited are often actually not experts. When I look at some of them, obviously some of them are experts, but everyone seems to have an opinion. And as long as you know how to write AI, you're now an AI expert on LinkedIn. And all sorts of strange stuff has been proposed in the last few years around AI. Like there's this person here, Elisej Yudkowsky. He wrote an open letter and said something like AI would cause the end of the world and we would have to cut compute time. So we should shut down all large GPU clusters and shut down all the large training runs. This would add certainty then and add a ceiling on how much computing power anyone is allowed to use in training an AI system. So I'm just reading out what he wrote. I didn't come up with that kind of stuff. And all GPUs that are sold should be tracked. And if intelligence says that a country outside this agreement is building a GPU cluster, one should even destroy that nation with an airstrike or their data center. I think that is really creating harm to humans and not the AI. But I don't think that this was actually a joke. I think he was really serious about that, the way he wrote it. So I'm confused, because you're scared that the AI may kill humans, but you kill humans that want to build an AI. So I don't know. But this stuff is being proposed. And now I want to know from you, do you think the end is near? Will AI end all of this here? Do you see largely positive aspects in AI or largely negative aspects in AI? Let us know. Maybe raise your hand. Yeah.
I don't know. I think it itself doesn't destroy anything. Of course, there's some issues with legal and with the energy consumption, but within its boundaries, it's still a tool. Like we use a calculator for math nowadays. And if you would tell a student, hey, don't use a calculator, it would be stupid. But now you say, hey, students, you shouldn't use ChatGPT to write your assignments. So I think you can't really do that.
Yes, I totally agree. It's eventually a tool, and like with any tool in the wrong hands, you can cause damage, but the tool itself will not cause the damage. And even a spoon, you can eat with it, or you can use it to someone's disadvantage. That's why we don't ban spoons. I'm even not talking about knives. Let's see if there's anyone online who wants to share your thoughts. If you think the end is near or not, let us know. This is here actually from the movie I, Robot from some 20 years ago. I guess all of you have watched it, right? But I think quite unrealistic, at least at present time. And now the question is, could the Terminator become a reality soon? So could this happen anytime soon? I like those Terminator movies, but I think they are purely science fiction. And one person here says the end is not near, but certainly some jobs will be lost. And that's why a lot of people seem to be afraid of it. Yes, I think that's a good comment. So do we have to be worried? What I have noticed in the last 15 years or so is that more and more specialized AIs have made enormous progress and started to outperform humans, be it in radiology, quality inspection, writing texts, whatever. And some of these AIs even outperform experts, like in medical diagnosis or in quality inspection. So does that mean we have to be worried? And there's this term called a singularity that refers to the point in time when machines would become more intelligent than humans. And how near is the singularity? Earlier today in the morning, I referred to what Mr. Kurzweil, Ray Kurzweil said. He said the singularity would be there by 2029, I think. And there are a lot of fears spread by numerous researchers. And actually, I like what Andrew Ng, who I met in Davos, said some 10 years ago or something. Because he was asked, is the end near and can we actually stop it, that AI turns evil? And he compared this to traveling to Mars. So he said, right now, researchers and engineers are working on sending humans to Mars. And so are AI researchers working on the next steps in AI. Some researchers are even thinking beyond this in AI, and some researchers in aerospace are thinking about how to send humans to Mars, not only for a while, but maybe how to colonize Mars for longer. Far away, but could be a goal. But absolutely no one right now is concerned about overpopulation on Mars and trying to prevent it, because it's just too far away. Because you have lots of preliminary steps you first need to follow before that ever could become an issue. So you're today just not productively able to prevent this. And so that's what he said, that he right now cannot productively work on not turning AI evil, because there's just a lot of preliminary steps that you would need to take before that ever became a concern. Some people then obviously suddenly it could go super fast and you don't have any chance to stop it. But well, the AI is still part of a system, and a system has boundaries. And obviously, we could already build killer robots today. But we don't build this, and we have system boundaries that wouldn't allow this to happen, because such systems could always turn against our own troops. And that's why military doesn't want fully autonomous killing systems. But we'll talk more about AI and military in the next chapter. Some of my thoughts is, I think the fear of an out of control AI is exaggerated at present time. And what I feel, a lot of these fears that are spread, and I created these slides here already like 7 years ago or something. So it's nothing new because of ChatGPT, and my views are still the same. I think a lot of these fears are often spread by people who do not work on AI and who do not possess a knowledge of AI. There are obviously some exceptions, but the majority is not from AI. And obviously, reaching the singularity and then building an artificial general intelligence is something super interesting, because such an artificial general intelligence would not just be better in certain use cases, but it could be better as a whole than humans. But how can this be achieved? I don't think we are anywhere near the singularity or artificial general intelligence, and ChatGPT is not near anywhere either. I think in order to achieve this, we would probably have to rethink also some parts in computer science as a whole, not just in AI, to achieve artificial general intelligence. And there are various predictions. So Kurzweil says in 29, some people say it may never happen, and now we need to find something in between. And there's a very good book about that, also appeared 9 years ago. It's called The Technological Singularity, appeared with MIT Press, and was written by Murray Shanahan, who was actually one of my professors when I did my master's at Imperial College. And in his book, he does not attempt to make his own prediction, because he feels if you make a prediction, you're just wrong. But rather, he assesses predictions of others. He presents them, compares them, assesses them, and evaluates what you need to fulfill in order to get there and what certain consequences of all of that could be. And he argues if the singularity happens, or when it happens, and we have an artificial general intelligence, this could be the last great invention made by humans, because such a thing is then smarter as humans. And if you just give it more compute time, it could become smarter and smarter. But that's an assumption. We don't know if this really happens. But right now, we can hardly prevent this from happening because there are just too many preliminary steps to do. And I think there are far more concrete concerns like changes to the job market, loss of jobs, and further automation, which will also create pressure on salaries. But we also have another section to talk more about the jobs market. But I think these are much more concrete issues than some AI turning out of control. Deep fakes are an issue. Deep fakes were mentioned here. We'll talk about them also in the legal chapter. And one student here says, from his perspective, he believes that the singularity may not occur because humans are unlikely to merge their brains with machines to achieve this goal. Instead, individuals might use technology to enhance their own abilities for improved understanding and performance, potentially leading to a situation where human evil could be transferred to AI systems rather than a hypothetical superintelligent AI. Yeah, I think there's truth to that. We will see how all of this evolves, but thanks for your comments here in the chat. And when it comes to this terminology in the last few years around AI getting out of control, AI being trustworthy, there's also a term that sometimes appears, and I just want to mention it very briefly. It's assurance. And assurance is sometimes a term used around military or government, and assurance is a feeling of confidence in your abilities. And then this new term, AI assurance, has been coined, and AI assurance refers to a range of services for checking and verifying your AI systems and the processes you use to develop them in order to provide reliable information about the trustworthiness to potential users. So it's safe development, checking, and so forth. That essentially is what AI assurance refers to. And there are also events around AI assurance. There's even the AI Assurance Club, which is very concerned about this. There was an event like 2 years ago, and I think it was online, and I also gave a speech there, and there were some notes at that time available. Should be still online. Feel free to take a look at that. It was about AI assurance and Industry 4.0. There's another term that is AI alignment, and alignment. There are so many new terms: trustworthiness, assurance, alignment. Sometimes it's even difficult for me to keep up with all these terms. And I'm sure until next year's course, there will be more terms. And AI alignment aims to steer AI systems towards humans' intended goals, preferences, or ethical principles. That's what one of the definitions says. So we want to align AI systems with our core principles. And there's a lot of beliefs or rumors on the internet that AI was unsafe, and all the AI systems would finally collapse, and this would cause the end of the world. I think personally, AI is overall quite safe and does work if you know how to build it. And I also wrote an article with a Chinese magazine sometime last year about this. And I said, AI is actually safe and works. But you need to do a little bit more than just use scikit-learn and build some predictor. there's lots of interesting theory, for example, around confidence in models. Because imagine you have a regression model, and the fact is, whatever output you make in your regression model, most likely it's wrong, because it's not just exactly that value that you're predicting. The crown or the actual result will be slightly different if you can predict some real value. So it's actually more interesting maybe to predict an interval in which you're most likely to have the value. And there are models for this, like Gaussian processes. You can use them for both regression as well as classification. They give you some confidence, some interval where most likely the result lies. You can also use lots of other methodology, like conformal prediction. Conformal prediction is also something we'll see in the big data course next semester. It's an approach that you can plug on top of nearly every regression and classification model to learn about the model's confidence. Because you're not just making a prediction, but the model will also tell you its confidence. And there's lots of theory. Already decades ago, it was proposed about how you can evaluate hypotheses, how you can assess if your model is actually good or not. This is from chapter 5 of the famous machine learning book by Tom Mitchell from the 90s. So he was already concerned about this. How can we actually assess which classifier is better? And you can evaluate such hypotheses. So there's lots of theory available how to build safe AI that works. There's lots of theory around explainable AI. And it still will make mistakes, that's sure, but there are ways we can reduce the error. And if humans make errors, so the AI will eventually, because we also need to get the training data from somewhere. And I think we just apply the same standards to humans and the machine. A lot of these concerns will probably just disappear. But I also heard from politicians that this was not enough from their perspective. They said the AI would have to be far better than humans, otherwise we wouldn't be allowed to use it. But I think if it's already as good as humans, we can already benefit a lot. And I've mentioned explainable AI. And since we've done lots of content today, and you should still today discuss a little bit and connect with each other to already explore some potential seminar topics, the lecture part for today is over. We'll continue tomorrow at 8 here on campus. We'll have a guest speaker and then a second guest speaker. I'll continue with this chapter and the next chapter. And I hope many of you can be on campus tomorrow to engage in the discussions because this is really your course. And if you live in Deggendorf, you should make sure you're here on campus. So take time now to connect to the others. Also check in iLearn. There's a forum to form groups and connect with each other for your seminar presentation, find some topics, and whatever questions you may have also on the seminar topic, whatever, let me know tomorrow. And I look forward to seeing you tomorrow. Take care.